Hello everyone, welcome to another tutorial about the electric potential energy. Here we're going to cover this example. An electron is released from the rest in the region where we have uniform electric field with amount of 5,000 Newton per coulomb in this direction. We're going to consider the positive x direction in this direction. So the electron move in the vacuum, no friction, and we can ignore any gravitational force on the electron. The question asks us what can be the speed of electron after it has moved a distance of 10 centimeters. So we know that if we release the electron in the uniform electric field, the electron is going to move in the opposite direction of the electric field toward the positive plates of the capacitor that generate this uniform electric field. So, if I wanted to calculate the speed of that, so the displacement of this electron is going to be in the opposite direction of the electric field because it is released and it has a tendency to move toward the positive plates. So what I'm going to do, I'm going to use the conservation of the mechanical energy. Conservation of the mechanical energy. So because there is no friction and so the initial mechanical energy is going to be equal to the final mechanical energy. The initial mechanical energy consists of the kinetic energy and electric potential energy at the initial point, and at the final point, kinetic energy and electric potential energy. So the question said that it released from this rest. So it means that the initial kinetic energy is 0. We are looking for the final kinetic energy to be able to calculate the speed of electron after its movement. So the kinetic energy at the final point is going to be the initial potential energy minus the final electric potential energy, which is the negative sign of the change in the electric potential energy in this displacement. We know that the change in the electric potential energy is equal to the negative sign of the work which is done by the electric field in this displacement. So the final kinetic energy is going to be equal to the positive sign of the work done by the electric field, which is related to work energy theorem. So if I open the work, which is charge, electric field, this refers to the force multiplied with displacement. So on the other hand, from the left-hand side, we have kinetic energy that I'm going to open it and show the relation of that with the speed of particles. So we are looking for the speed. Now, let's change the color. So the speed is going to be the square root of 2 multiplied with this term, charge, electric field, displacement, all of them under the square root over the mass of a proton, or mass of an electron here. So what we have an electron with the charge of a negative electric field, which is in the positive x direction,